Hi and welcome to my new video. Today I will illustrate the blog post about commits and transactions I written on my blog waitingforcode.com. So I will use 5 different applications and each one will simulate a concurrent data producers. I will start with the first one where, as you can see here, there are 2 threads and each thread performs some updates on top of the same set of rows. Typically it will be always one row modified and the modification will be different. I'm expecting here to get some concurrency exception from one of these processes. Let me run the code and show you a little bit what happens under the hood. So Delta Lake is attempting the first commit. That here it will not conflict at all because it's the table creation, and we are waiting now to see these print messages. Yeah, we have just started the concurrent update, and now we can see what happens with the commit log. First, there is the first attempt for the update, and now is the concurrent one, and for this we have this file already exists exception I'm explaining in the blog post, and because of that typically this exception means that the commit already succeeded and it can be retried. But the problem is that when you retry this commit, Delta Lake will try to see whether the retry can still apply on the same type of files, or whether there are some new files that are not included. And typically here there are some files that are not included, then that you will see that later in this exception message. So there is other transaction that will succeed, of course, and the exception message clearly states that there were some concurrent updates on the root table that are not included. Now it's time for the second example. In the second example, I'm testing the theory that we could concurrently update a delta table if we explicitly target if we explicitly target files located in, if we explicitly target rows located in different files. So that's the reason why I'm fetching this first IDs stored in each file here, and later in my concurrent producers I'm taking just two first files with first IDs, of course. And you will see that despite that fact, so despite physically manipulating different files, this will still not work. So let me run the code. Okay, you can see that we have different updates, and yes, at some point it failed. It failed with exactly the same message as previously, so there are some files added to the root of the table, and this root of the table is a kind of keyword, because if you explicitly target different partition in your update query, well, Delta Lake will, as you know, skip the irrelevant partitions, so it will directly skip the files that might be concurrently changed. And you will see that in this code snippet that is exactly the same, but here I'm explicitly defining the partition name. So I have my partition by expression here as a part of the predicate. And because of that, this time the update will not fail. So you can see we're starting the concurrent updates. And once all the updates are executed, we will decrement the countdown, and later we will select the table by explicitly choosing the modified rows. So when it comes to the updates, we will set this value for the row number 4 and this value for the row number 5. Let's wait a few more minutes, a few more seconds, and yes, we have our query results, and you can see that we have -145 and -104. Now I will do the count. I will run the counter example. So here I'm still targeting rows located on different partitions, different physical partitions. But the problem is that I don't have this partition attribute in the predicate. And because of that, Delta Lake will read all the data. So it will read this famous root table. Let me show you that. Okay, the update has just started. And yeah, we have the same concurrency update error mentioning the root table, right? You can see that, well, it doesn't explicitly mention the root table, but the partition, but yeah, the reason is exactly the same. It's just conflicting commit with concurrent append exception. And now I will run the last code in the debug mode. Here, as you can see, I'm doing insert operations from two different data producers. And as you already know, this insert operations doesn't modify existing data. And as a result, I will be able to run them without any concurrency issues. And it will be a great example to show you the automatic conflict version resolution. So I will run the code in debug mode this time. Okay, the comment is not relevant here. Okay, we are committing the first time, and this is the table creation. And we will start soon. Okay, we will start soon this inserts. We have the inserts. We start the first attempt for one of them. Next, we will probably start attempt for another, and here we can see that there is some conflict in the first, so in the second version of the on the table, and this time we will try another attempt, and it will succeed because eventually the conflict because there is no conflict, and the single conflict in fact is just the commit log version. That can be simply upgraded with this automatic resolution method I'm showing you here and that I'm explaining in the blog post. And you can see that all is just fine. And that's all for this video that illustrates some of the ideas I presented in the blog post. And if you are interested to see them more in details, I invite you to the article which is linked just in the description below this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.